Today's video is about factoring polynomials. So we're going to factor binomials, trinomials, polynomials. We're going to use different patterns, the strategy called grouping, and all sorts of different variety of methods. But all basically to rewrite something as a product of two or more things. So our first one here is a quadratic trinomial. It's kind of like the classic setup. What multiplies to x squared would be like x and x. And what multiplies to 60? Well, there's a lot of options. You could use like 1 and 60, 2 and 30, 3 and 20, 4 and 15. I'm going to need to have my 5 and 12. Because this is a negative, that's going to tell me that in my two parentheses, one is going to be positive and one is going to be negative. So basically, I want that if I'm going to combine these, when I subtract them, it'll net me positive 7. So I'm going to place 12 there and 5 there. That will give me a 7x in the middle. Notice I'm not solving here. I'm not doing anything else with it other than just factoring it into the two pieces that will multiply to that trinomial. A common one that's used is what's called the difference of squares. And so you see the format a squared minus b squared factors to a minus b times a plus b. So for example, if I had x squared minus 16, I could factor that into x minus 4 and x plus 4. Because x times x is x squared and 4 times 4 is 16. So that's the difference of squares. Notice that one negative and one positive are going to cancel each other out for that middle term. Oops, I don't know why I did that. So here, when I go to factor this one, I have 9x squared is a perfect square, and so is 1. So when I go to factor, I have 3x minus 1 and 3x plus 1. Take a minute, pause the video, and try these two problems, please. Hopefully you did that. Looking at this right away, it doesn't seem to follow difference of squares, but I actually have a greatest common factor, or a GCF, in here first. So I have 162x cubed minus 128x. I can actually pull out a 2x out of both of those. I'll be left with 81x squared minus 64. There's my difference of two perfect squares. So I'll have 2x, and then I set up here 1 plus 1 minus 81x squared. Well, that's really 9x and 9x, and 64 is plus 8 and minus 8. Final answer. X to the fourth is also a perfect square. It's actually x squared squared. So I'm going to start with x squared and x squared. 1 plus 1 minus, and we have 4 and 4. But wait, there's more, because this piece right here can actually be factored again as another difference of squares. Difference is because it has to be a subtraction. X minus 2, x plus 2. And we still have this x squared plus 4. This one cannot be factored further, because it's a sum of squares, not a difference of squares. So taking a look at this one, you almost want to do it the same way, but it's a little different because it's a difference of cubes, right? This is a perfect cube, and so is 8. 8 is like 2 cubed, which is really 2 So what I need to do instead is the sum or difference of cubes formulas, which look like that. So a cubed plus b cubed factors to the quantity a plus b multiplied by the quantity a squared minus ab plus b squared. And if I have a cubed minus b cubed, it's a minus b multiplied by the quantity a squared plus ab plus b squared. So as we're taking a look at this, okay, you see all of the pieces are the same except for the signs, basically. And this one's a positive, that one matches there. And this one's the opposite. Okay, this last one is always positive regardless. And then here on these, that one and that one match. And then I have my opposite. So it follows same, opposite, always positive, or SOAP to help remember it. So let's go back to that last one. Oh, where did it go? Okay. So our binomial is going to be x minus 2, because x times x times x is x cubed, and 2 times 2 times 2 is 8. Notice this is that same negative that I have there. Now this one's going to be x squared. This is same, opposite, and this one will always be positive. Now this middle piece is going to be the product of this one and this one. So 2x. Notice when I'm doing that, I'm not taking the positive or negative with it. I'm just taking the numerical piece. And then this last one here is 2 squared, which is 4. So if I want to check that I'm right, I could actually always multiply these out. Get x cubed plus 2x squared plus 4x, and then minus 2x squared. See those canceling already. Minus 4x. Ooh, another set canceling. That's just what you want to see. X cubed minus 8. It does really equal that. Okay. All right. Take a moment, pause the video, and try this one. And yes, 216 is a perfect cube. And yes, I do think you should know some of these perfect cubes. So, 1 cube 1, cube 8, 3 cube 27, 4 cube 64, 5 cube is 125. Ooh, that's a good one. 6 cubed is 216. Ding, 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 ding. All right. So hopefully I'll write out a few more. 7 cubes, 343. 8 cubes, 12. 9 cubes is 729. 10 cubes is 1,000. So, all right. So we all agree this is 6x quantity cubed, and that's 5 cubed. So when I set up this first parenthesis, I'm going to have 6x plus 5. And so that's that same. I'm going to have an opposite and then an always positive. This last one is going to be 25. That's 5 squared. And then 6x times 5 is 30x. Now this is the spot where I bet some mistakes might have happened. This spot is going to be 6, the quantity 6x squared, which is going to be 36x squared. Common mistake right here is forgetting this coefficient. A lot of people would write 6x squared, but that would not give me the 216 we're looking for. And that's my final answer. These cannot be factored any further, so we are done at that spot. And that's true, they're never going to be factorable any further. All right, just three more strategies. Next type. This is what's called a quartic in a quadratic pattern. Okay, or you have a degree 6 in a quadratic pattern here. So basically what I want to do on this is kind of treat x squared as u for a minute. And what I would have here, that means x to the fourth would be u squared. This problem is really the same as u squared plus 9u plus 20. That's really easy to factor. It's just u plus 4 and u plus 5. Because 4 times 5 is 20 and they add to 9. But really, my problem was not with u's. Our problem, so these two really should be x squareds. So really it's x squared plus 4 minus x squared plus 5. Go ahead and pause the video and try the problem below. Hopefully you did. So in this one I would make my u x cubed, which would make u squared minus 26 u minus 27. Factor u minus 27 and so really that's x cubed minus 27 and x cubed plus 1. But wait, there's more. Hopefully you noticed that this is actually a difference of cubes and that's a sum of cubes. So I can actually factor both pieces again. I get x minus 3, x squared plus 3x plus 9. That's factoring this piece out. And then this one's x plus 1, x squared plus x plus 1. Tricky. The next strategy is called grouping. And grouping is used when you have a polynomial with 4 terms. You can actually do grouping with more than 4 as well, but usually that's the most common spot you're going to see it. When we do by grouping, we look at 2 things at a time, or sometimes even 3. But if I look at these two, x cubed minus 2x squared, I can pull out an x squared out of those two. I'm left with x minus 2. When I look at these two, 5x minus 10, I can pull out a 5 as a GCF out of those two. And I'm left with x minus 2. Now grouping only will work when this piece here and this piece there match. If they don't match, grouping's not going to be a strategy that's going to be effective. So basically what you're saying is I have 5 apples and another 2 apples is saying I have 7 apples, or combining x squared plus 5 of those apples. Okay. Take a moment and pause the video and try this problem. Alright, so I'm going to look at the first two, and I can pull out an x squared and left with 4x minus 1. I look at these two, I can pull out a negative 4 and left with 4x minus 1. Again, if I get similar but not the same, I might want to check for pulling out a negative, or if they're another GCF. So one of my factors will be x squared minus 4. The other factor is x minus 1. But wait, there's more. This piece can be factored again because that's a difference of squares. X minus 2 plus 2 and 4x minus 1. Last type looks like that. Whoa. I'm going to use the strategies we've been practicing. So I'm actually going to use that u strategy again. I'm going to say u is x plus 5. That would and so everywhere I have this parentheses of x plus 5, I'm going to rewrite it as a u. U squared minus 4u plus 3. Well, that factors to u minus 1 and u minus 3. And it gives me a negative 4 in the middle, positive 3 at the end. But wait, my problem had really x's in it. So I'm going to go back and change my u's to x plus 5. And x plus 4. Really? X plus 4. Because the parentheses aren't doing anything on this one. Neither are those. The next answer. Final answer. This is especially, and I'm sure when most of you saw this problem, you wanted to expand that out, combine, and then factor. The reason I'm doing it this way is if I had had two different variables in those parentheses, I would not be able to factor it once I had it all expanded. Okay? And this concludes our lesson on factoring.